My name is Kainton, the Tech Pro, and today we are going to be answering this question that says differentiate between sensitivity and specificity. So this is a typical problem you might encounter in machine learning quiz or exam. And one thing about questions like this is if you look at it, you find out that there are two terms mentioned here. This is specificity and sensitivity. And the interesting thing is sometimes in machine learning might actually have different names that they can be used, and that can actually be confusing. So let's look at the meaning as I've explained in my website. Let's first highlight some basic things. One, these two terms are related to classification. Precisely, they are used to describe the performance of a binary classifier. A binary classifier. So that is one thing you want to have in mind. All right. And again, let's now look at sensitivity. Sensitivity also has a name, true positive rate. So sensitivity is the same as, make no mistake about it, is the same as true positive rate. And specificity, I'm going to use another color of pen. Specificity is true negative rate. Specificity is the same thing as true negative rate. So let's start with sensitivity. So if you have sensitivity, a classifier, that classifier actually takes data. For instance, you have X, you have T, let's call it T, X1, X2, X3, X4, X5. And you have two classes, C1, C2, C1, C1, C2. So if we are given another data, let's say X6, which class will it be? Will it be C1 or C2? Your binary classifier will take a look at all this data and then be able to classify it correctly. Now, if you have this classifier and it correctly classifies some, of course it doesn't, sometimes it may fail actually. So sensitivity simply now means it's trying to calculate the total number of positive correct classification and divided by total number classified. So let's call this T1 because let's say T1, C1, C2, C1, C0, C1, C0. So let's say C1 represents positive classification and C2, C0 represent negative classification. So in this case, if we want to measure the sensitivity and we say is the same as total positive correctly classified over total number classified. All right, so let's say we have two new data points. Let's say we have X6, X7, X8, all the way to X, let's say N. Okay, so now your classifier have classified N items, and it correctly classifies, let's say, 20. Okay, so let's say N is equal to 28 items classified, and it correctly classifies 25, and it fails in classifying 3. So this 3 that it fails to classify is a penalty for your classifier. Therefore, the performance of this classifier in terms of sensitivity will be 25 correct classification over total classifications. So, and that will give us 0.89. So why it's called true positive rate is because it's calculating the total number of positive data classified over total number of correct positive classification and total number over total number classified. And the same thing goes for specificity. In this case, if it correctly classifies, let's say, if it classifies 30 items and correctly classifies 25 negative items, meaning that if you count the number of C0 and divide it by total number classified. So in this case, if it fails 5, it means it's classified 30 items total classified, let's say 30 items classified, and it fails in classifying 5. And you are talking of negative classification. So it means that the specificity will now be 25 over 30. And 25 over 30 is going to give us 5 over 6. 5 over 6 should be, I cannot work it out at this time. Okay, maybe 0.7 something. So this is what the specificity is all about. So now I want you to take a look at my website, kindtonthegenius.com, is in the description box. So explanation here is very, very clear for you. In case you meet it in an exam and you explain it in this way in my website, I explain in my website, you are going to actually get 100% in this question. So I'm going to stop here, and also like to remind you to subscribe to my channel if you've not subscribed to my channel. Also leave me a comment if there's something you would like me to do.